In this problem, we are going to discuss the dominance property to solve a game problem when minimax not is equal to max. Then, how we'll solve a 2% zero sum game by applying dominance property. Okay, this is the problem. Player A and player B. Player A has three strategies. Player B has three strategies. These are the payoffs. Now I am not going to discuss in detail how the value of minimax maximum is done. Maximum value of minimum value is this, and the minimum value of the maximum value is this. And minimax is equal to +2 and maximum is equal to -3. I am not going to discuss in detail how it has come. If you have any doubt, then you may check on my previous video where it is discussed in detail how minimax maximum value is done. Okay, so in this case the minimax not equal to max. Then how we proceed to solve it? That's why hence go for application of dominance for reduction of matrix. Till now we have not discussed the dominance property. Step 2. What is dominance? You see carefully the payoff matrix, then you will see for player B, if player B is taking the strategy 1 or strategy 3, then you will see for all the elements of strategy 1 is less than the corresponding element of strategy 3. Whatever the payoffs, that is in favor of player A. That's why in this case you see -4 and +3. That means 3 is higher. That means player B, if takes the strategy 3, then player A will get more. That is +3 instead of -4 if player B takes 4. In this way, -4 +3, -3 +6, that means 6 is higher than -3, and 2 in this case it is 4. So all the elements are higher corresponding to all the elements of strategy 1. That's why player B will never select the strategy 3. Strategy 3 has no meaning in this problem, as player B will not take the strategy 3. Why will not take strategy 3? Because all the elements are higher, corresponding elements are higher in the case of strategy 3. Because the values will be in favor of A. That's why player B will delete the strategy 3. This is the criteria of dominance. That means strategy 3 will never be selected by player B. That way it will be deleted. Okay. And the revised matrix will be like this: -4, -3, 2, 6, -3, -3. And it is deleted. The revised matrix is this. Again, we will check by minimax maximum theory whether there is any equilibrium point, saddle point, or final solution of the game. That's why I am not going to discuss in detail. This is the application of minimax maximum theory. The minimum value is -4, -3, -3, and the maximum value 2, maximum value +6, the minimum of this, and both minimax and maximum are not same. That means again saddle point does not exist or no solution available. For that reason, again we have to apply dominance property if possible to reduce the matrix. Now carefully you check for this matrix. Here player A will never select strategy 2. Why player A will not select the strategy 2? Because all the payoffs are plotted or written in favor of A. You can check 2 is more than -3, and this is same. That means player A will not be interested to select the strategy 2, because if he selects 2, that means he will get lesser than 2, as both the elements are higher or at least same for strategy 3. That's why player A will not select the strategy 2, and we can say the strategy 2 is dominated by strategy 3. In the case of player A, we say that strategy is dominated which will be deleted. But in the case of player B, we will say the strategy will be dominated, which is not deleted, which is remains kept for the corresponding other strategy. So in this case, the strategy 2 will be deleted and the revised matrix will be like this: minus 4 plus 6 to minus 3. And this is the reduced matrix, payoff matrix, in which for player B the strategy 1 and 3 will be available, and for player B the strategy 1 and 2 is available. Again we have to check whether shuttle point is available or not. If shuttle point exists, that is minimax is equal to maximum, then we will stop here and we will get the solution of the problem. So again we are applying minimax maximum criteria that I am not going to discuss in detail. Here maximum value is minus 4 and minimax value is minus 2. As for the same process we have discussed earlier, but both the values are not same. That means again minimax not is equal to maximum. That's why the solution or shuttle point does not exist. Then what we will do? Again you will try to reduce the matrix, but it is not possible. You can check it, because for this column and this column, this is lesser than this and this is higher than this. In this way the combination retains in such a way you cannot reduce. Then what we will do for solution? We have not reached to the solution, and for that purpose we have to move for another technique which is called probabilistic technique. And a mixed strategy is a case of mixed strategy. That means you have to apply mixed strategy to get the solution of the problem. Mixed strategy means mixed strategy means player A and player B has to apply more than one strategy. How it will be applied, that I will discuss later on. That means only one strategy is not sufficient to get the best value or optimum value of the game problem. Here only we have reduced the 3 by 3 matrix to 2 by 2 matrix with the application of dominance property. Now we are going to discuss the process of application of mixed strategies. How we determine the mixed strategies and the value of the game. That means our next topic will be the mixed strategies in solving game problem. So I am going to discuss how to apply mixed strategies for solving 2 by 2 game problem. Okay. For that it is better to develop the formula for getting the values or probabilities for application of the strategy. And this formula can be developed by 3 methods: algebraic method, calculus method, and linear programming method. Though it is a mathematical part, however, we will discuss the algebraic method for getting the value of probability and for developing the formula. So we are taking the 2 by 2 matrix, and I am taking here the general value so that we can apply the formula for all problems where mixed strategies are required to be solved to getting the value of the probabilities to be applied for the strategies. Okay, this 2 by 2 game problem is this. For player A is the strategy 1, 2. For player B the strategies are 1 and 2. And the payoffs are A, B, C, D. We have taken the general value. For solving the application actual problem, we have to put the numerical values in place of A, B, C, D, whatever it is. Now I am going to start to develop the algebraic formula. Suppose P is the probability of application for strategy 1 for player A. I have noted that things here. We will read it carefully, then we will understand. If P is the probability for application of strategy 1 for player A, then 1 minus P will be the probability for application of strategy 2, as the sum total of the probability is 1. If we add P plus 1 minus P, then we will get the total 1. That means if we know the probability of value of P, then you can find. Now, from the side of the player P, say the probability for application of strategy 1 is q. Then 1 minus q will be the strategy for 1 minus q is the probability of application for the strategy for player B. That thing is also written here. Now, expected value of A is player A when player B is taking the strategy 1, then what will be it is equal to A into P or P into A plus 1 minus P into C expected value. That is expected value of player A when player B is selecting strategy 1. In this way also you can find out expected value of A when player B is taking strategy 2 will be P into P plus 1 minus P into D. For the condition of equilibrium, equilibrium means if player B is taking strategy 1, whatever the expected value to player A will be the same as when player B will select the strategy 2. That is written here, that is the equilibrium condition. In that case, both the expected value will be same as it is the equilibrium situation. And I put it the formula only, expected value of that is, this is A into P plus C minus P. So this way if you solve, then you will get the value P, you can check it. Similarly, for the side of player J, it can be shown. I have not shown it in detail, the process is same, only if the player A is taking the strategy 1, then expected value of P will be, this A will be Q into A plus 1 minus Q into B. In this way it can be done. After solving, you will get this value. I have not shown it in detail here because the process is same, and putting this formula you will get the value of the game will be this. And this is the general formula for finding out the value of probability for strategy 1 and 2 in a 2 by 2 game problem for player A and for player B and the value of the game. It is very easy, it is not very difficult to keep it in your memory. There is a system how you will keep it in your memory. This is the game problem 2 by 2 game problem A, B, C, D. You see for probability P, D minus C and this is the numerator. For P you will take this one, D minus C, and the denominator is same. The cross is this is the process of cross. AD minus B, A plus D minus B plus C, A plus D minus B plus C, denominator. The denominator is same for all the formulas, A plus D minus B plus C. The denominator is same for all the cases. And numerator for P, it will be D minus C. For Q, it will be D minus B, D is common. And for the value of the game, AD cross AD minus BC. That way you can keep in your memory the formula. Because in exam, when you have to solve the problem of these strategies, then you can use the direct formula. Only you can mention after applying the algebraic formula or whatever it be. And the formula will be like this. By mentioning that you can solve it. But in our last problem, when we have applied dominance theory, the last reduced game problem was this, and which you cannot reduce further. You had also checked there was not any minimax maximum. There is not any the minimax not is equal to maximum. That's why you have to move for the mixed strategies. Then how will you solve it? You see, if you apply this general formula, then what will be the values? Then A, B, C, D. A is equal to minus 4, B is equal to 6, C is equal to 2, and D is equal to minus 3. These are the numerical values for each variables. Now, for getting the value of P, means probability of strategy 1 for player A will be P is equal to D minus C, numerator and denominator will be A plus D minus B plus C. Just to put the values, then you will get 1 by 3. If the value of P is 1 by 3, then the value of 1 minus P will be 2 by 3. In the same way, you can also find out the value of Q. You put the D minus B in this formula, then you will get the value of Q will be, you can check from E by 5. Then 1 minus Q will be 2 by 5. Okay, and then what will be your solution, and you can find out. If you put all the values, then you can see the value of the Q will be. In this way, you can solve the mixed strategies. And how you will apply the mixed strategy, that I will discuss separately. Then your strategy will be, if you note down it, I'm just writing here due to shortage of space, I'm writing the answer. Strategy for layer A. Strategy for layer A will be 1 by 3 for strategy 1, and 3, that is 0, and 3 will be 2 by 3. And strategy for B will be 2 by 5, sorry, 3 by 5, and 2 by 5 and 0. And the value of the K will be 0. In this way, you will write your answer. Thank you. This is one problem. I will try to solve another problem by applying mixed strategies. Okay, thank you.